Hey folks, let's talk about some rules associated with probability. Namely, we're going to talk about complementary events, a rule called the addition rule, and what mutually exclusive or disjoint events are. Let's get rolling. Mutually exclusive events, also known as disjoint events, are two events in which they cannot occur simultaneously. So for instance, consider a regular coin, right? You've got heads and you've got tails. They cannot occur together, right? You can't flip a coin and it be a heads and a tails at the same time. So in a single coin flip, heads, tails would be considered disjoint events. Cool. The other rules I would like to talk about today, I actually want to demonstrate first in the context of an example. Let's consider a standard deck of cards where there are 52 cards in a deck. And I know it's probably been a while since maybe you've seen a deck of cards. So here is a little image I stole from the internet somewhere. There are 52 cards, and the way these are organized, there are 4 suits. There are the hearts, the diamonds, the clubs, oh, I don't know if I can draw this, and the spades. So a quarter of the deck is hearts, a quarter of the deck is diamonds, etc. And we've got ace, sometimes considered a 1, 2, 3, 4, all the way up to 10. And then there are the face cards. Here we've got the jack, queen, and king. So just a brief review there. There is 1 suit for each of these valued cards. So there's 1 heart, that is a 2. There is 1 jack, that is a heart. There is another jack, that is a diamond. Okay, so let's suppose you're going to select 1 card at random. And what I'm also going to do here is define a few events in shorthand because we're going to refer to them a few times. Let's let queen be represented by a Q. So this is the event that a queen is selected. K is going to represent the event of selecting a king. And I'm going to let S be the event of selecting a spade. So a spade is this card down here. I'll kind of fill it in with blue. I'm going to ask us some questions regarding the probabilities associated with selecting some cards, and that will hopefully demonstrate some of these rules up here. Let's determine the following probabilities. Here I have written the probability of selecting a queen or a king. And we're going to determine these using the theoretical or classical approach. And so we're going to count how many times does a queen occur and how many times could a king occur out of the 52 cards. And as we see over here, there are 4 queens here And there are 4 kings here. And so that is going to be represented by 4 queens out of the 52 cards. We've got 4 kings out of the 52 cards. And that gives us a total of 8 cards in which would satisfy this statement. So how are we going to combine these 2 fractions? That would be with a plus sign. Our answer here would be 8 out of 52. And yes, we can totally reduce that. Maybe we should, but I like leaving this in a non-reduced form because it shows our thought process in a way. Moving on to the next probability to determine here. This time we want the probability of selecting a queen or a spade. So looking back at our sample space here, we know that there are 4 queens that I'm going to try to highlight in blue here. And there are also how many spades? Well, we know a quarter of the deck are spades. So all of these as well. And we're going to have to be a little careful here. Let's see why. Adding up the 4 queens out of the 52 cards total, plus, count them up, there are 13 spades out of 52 total, because we've got the ace through 10, jack, queen, king makes 13. Now that's not it, because notice that in our image over here, we have actually double counted a card, right? This card that I'm circling in pink is the Queen of Spades, and we counted this card among the 4 queens, and we counted this card among the 13 spades. So we double counted this card. Therefore, we need to account for that. We need to get rid of that one card that we double counted. Now that we have this subtraction in place, our total here for our probability would be 16 out of 52. Awesome. Let's annotate this just a little bit. A couple notes I would like to make are, how come there was no subtraction on this first quantity? Well, notice because queens and kings, are they mutually exclusive? They are. So there was no way to double count in this first example, because the 4 queens and the 4 kings, there was no overlap. They cannot occur together. So that was in essence why there was no need to subtract here. However, with this second example, queen, the event of selecting a queen and the event of selecting a spade are not mutually exclusive. They can occur together, right? And we saw them occur together with the Queen of Spade right there. in pink. So since we double counted the Queen of Spades, we had to undo that. So we double counted. I'll need to scooch down here. So since we double counted that Queen of Spades, because the Queen and Spades can occur together, we had to undo that double count. Let's look at a couple more probabilities before we define these rules for the video. Let's look at the probability of selecting a queen and a spade. Now think about the word and versus the word or. Basically, this is saying that that one card needs to have both of these qualities. That is referring to the Queen of Spades, isn't it? So there is only one card that has both those qualities out of the 52 cards. This is sometimes called an intersection of events. This is the intersection between the event of selecting a queen and selecting a spade. Here is another probability that may be fun to consider. The probability of selecting a queen and a king. Well, here is another potential intersection. Can a single card be selected and it be a queen and a king at the same time? No, right? Because they are mutually exclusive. They cannot occur together. This would be a probability of 0. While we're here, let's just do one more probability. Here, this is asking the probability of selecting a card that is not a queen. Not a queen. Well, we know that 4 out of the 52 cards are queens, but the rest are not. And all the probabilities of all the cards put together have to add up to 1. And if you subtract 4 out of 52, this is saying all the cards except the queens. And that gives us a nice 48 out of 52. I think we've done an example of all the properties I want to show in this video, so let's formalize them now. The addition rule has to do with, well, addition. And this is the rule that applies when we see probabilities with the word or. So the probability of E or F, being general here, is the probability of E plus the probability of F. But if there was any potential double count, we need to account for that by subtracting that intersection probability of E and F. So this was very much like the queen or spades example. And this generally applies when we see the word or I suppose either or. Secondly, let's look at complementary event. The complement of an event is the chance that it does not occur, and this is often denoted as the probability of an event that does not occur or the complement of that event. And so here I've got E with a C in the exponent. This is the probability of the complement of E, and it is the chance that E does not occur. So what you do is you take the chance of E occurring and then do 1 minus that probability. That's going to conclude this video. We do have some more probability rules to discuss, but we'll pick that up in a new link. See you in the next video.